Hello, it's Mr. Lewis here. We're continuing with topic 7, rates of reaction and energy changes. And this video will look at energy changes. Now make sure your phone is off so you're not watching it and not be distracted on it. You have a calculator and a pen and paper to take notes with. If you're ready, we shall begin. So we're going to have a look at energy changes and what it means. Now, when a reaction occurs, there is a change in the energy. Now, you hopefully remember from your other lessons that energy cannot be created or destroyed. So that energy is either absorbed from the surroundings or it's transferred to the surroundings. We're getting absorption or transference. So make sure we're using those terms. So absorbed from the surroundings or transferred to the surroundings. When we're talking about the surroundings, we mean anything around it. What we're talking about is the actual chemical bonds themselves. So it's going into the chemicals. And we can measure the energy change of a reaction by measuring the change in temperature. If we see a change in temperature, we can say that there has been an energy change. And we'll look at what each of those mean. So some examples are, we've got salt dissolving in water. So that is an example of a chemical reaction. We do get an energy change there. Neutralization reactions. So that is where an acid and alkali mix to neutralize each other. Displacement reactions. So where one element displaces another from a compound. Or precipitation reactions. So where we're forming a solid. I've put there some of the equipment that we will use. That part in the middle is a thermometer. So we'll just label that so we know that it's there. That is a thermometer. And that will measure temperature. So we're going to measure the temperature. We normally put this into a polystyrene cup. So we put it into a polystyrene cup because that is a good insulator. So it is a good insulator. So it will stop any heat changes going out. It will just stay within the reaction. And I've got it there as well. I've put it into a glass beaker, again to help insulate it. And what we would do, we would put a mixture of solutions in here. So we've got a blue one, and we'll put a purple one in there as well. And we see a temperature either change going up or down. By doing it in a polystyrene cup, we insulate it so we get the best idea about the temperature change. Now obviously the heat energy could escape out of the top, so to insulate it even more, you might want to put a lid over the top. If you put a lid over the top, you are insulating it as best you can. And we've got two different types of reaction. Now, if a reaction increases the temperature of the surroundings, so the temperature goes up, it is an exothermic reaction. If it is an exothermic reaction, energy is released. So energy is transferred to the surroundings. So energy is transferred to the surroundings. The way to remember it, we've got at X at the start, so we've got exothermic. So X is the same as exit, so it will exit the bonds or the chemicals. So it's going to go out into the surroundings. Now, if a reaction decreases the temperature of the surroundings, it is an endothermic reaction. So in that one, our energy is absorbed from the surroundings. So our energy is absorbed from the surroundings. A way to remember that one, we've got two ways for this one. We've got the EN is the same as enter. So it enters the chemicals. Or our other way, we've got a D in it, and the D is down. So our temperature goes down. Temperature goes down, endothermic. Temperature goes up, exothermic. We want to make sure we get those the right way around. We're going to have a look at what happens and why we get endothermic and exothermic reactions. So I've got some oxygen and I've got some hydrogen, and we're going to make water with it. So to do that, we need to rearrange these molecules. We need to break apart the oxygen and hydrogen molecules. Now to do that, to break them apart, I have to put energy in, to pull them apart. Those covalent bonds are very, very strong. So I need to pull them apart. I need to put energy in. So I'm going to put some energy into my oxygen. There goes my energy going in, and it's going to pull apart those molecules. We've had to put energy in, so it's come from the surroundings, it's gone in. Therefore, this part is endothermic. So energy going in is endothermic. I'm going to break the hydrogen now as well. We put energy in, and the hydrogen breaks. So we can say that breaking bonds is endothermic, because energy has entered. That energy has entered endothermic. We're going to look at them joining together again. So we've got our molecules there. They've now come over to this side and they are there. I know I've not balanced it, but we'll ignore that for the moment. And I've made those bonds. Now energy went in to break them. It does the reverse when they get made. So the energy is going to come out. So our energy has been released. And we can say that making bonds is exothermic. Or we can say that energy has exited. So our energy has exited. So breaking bonds is endothermic, making bonds is exothermic. We need to make sure we remember the right way round that is. Now there may be times in your exams, particularly for the higher paper, where you need to calculate the energy change and work out if it is endothermic or exothermic. Now we've got a question here. Hydrogen and chlorine react to form hydrogen chloride. Calculate the energy change of the reaction, and is the reaction exothermic or endothermic? Now they will give you a table with the bond energy in it, with the relative bonds as well. They don't expect you to know these, they will give you that information. Now our first step for this is to write out and balance the equation. So for this I've got H2 plus Cl2 is going to make HCl. I'm going to balance it, so I'm going to put a 2 in front of here. So I've got 2 hydrogens on the left and now 2 on the right. 2 chlorines on the left and 2 on the right. I'm also going to write it out showing the bonds. So I've got H and H, that's my H2, plus Cl, Cl, that's my Cl2. It's going to make HCl. So I've got 2 HCls. That is my first step. A lot of time they will give this to you in the paper, but not always. Our second one is to work out the bond energy of the reactants. There are bonds that will be broken. So I've got my hydrogen, which is 436. So I've got 436 kilojoules per mole, plus my chlorine that I need to break, which is the 243. If I add those together, I get 679 kilojoules per mole. I'm now going to work out the bond energy of the products, so the bonds that will be made. And I've got my hydrogen chloride, which is 432. So I've got 432. Now don't forget, we've got 2 of them. I'll put 2 there, I've got 2 of them there. So I'm going to times this answer by 2, as I've got 2 of them. If I times that together, I get 864. Again, kilojoules per mole. My final part, this is to calculate the energy change. I do my bonds broken, take away the bonds made. So my bonds broken, my reactants, is 679. Take away the bonds made, we've got 864. So if I work out 679, take away 864, I get minus 185. My units, kilojoules per mole. You do need to make sure that you include the units, and sometimes your answer will be negative, sometimes it will be positive. It won't always be a positive number. Make sure you do your bonds broken or your reactants. Take away your bonds made, which is your products. Now this value is a negative value. Because it is negative, it is exothermic. So we have got an exothermic reaction. Negative values are exothermic. So remember, calculate or write out the balanced equation, calculate the bond energy of the reactants, the bond energy of the products, and then do the reactants or the bonds broken, take away the products or the bonds made. So here is a question for you now. So hydrogen bromide decomposes to form hydrogen and bromine. The balanced equation is 2HBr makes H2 plus Br2. And we've shown it there with the bonds on there. Now to calculate the energy change for the reaction, and is it exothermic or endothermic? So there are the bond energies. So please pause the video and have a go at trying to work it out yourself. You should now only be watching if you've worked it out. So we've already got our equation there. So I'm going to skip step 1. Step 2, I'm going to look at my bond energy of my product. So the bonds broken. So my bonds broken is my HBr. So it's these ones here. And that is 366. Now don't forget, I've got 2 of them, so I'm going to times it by 2. So I've got 366 times by 2, and that gives me 732 kilojoules per mole. I'm now going to work out my bonds made. Is my hydrogen, which is 436, plus my bromine, which is 193. So I've got 436 plus 193 equals 629 kilojoules per mole. I can now work out my energy change. So I'm going to do my bonds broken, take away my bonds made. So my change equals my bonds broken, which is my 732, take away my bonds made, 629. So I do 732, take away 629. I get an answer of 103 kilojoules per mole. There's no negative sign, so it is an endothermic reaction. So I have an endothermic reaction. This one, if I measured the temperature, it would go down. Well done if you got that correct. We're now going to have a look at our energy profiles. We've got our exothermic one and our endothermic one. Now, chances are they will ask you to draw these graphs in there. It might be a blank graph, there might be part you need to add onto it and add the labels. So we've got our X and Y axis. Now our X axis along the bottom is our reaction progress. So that is our reaction progress. And our Y-axis is our energy in kilojoules per mole. Now with an exothermic reaction, our energy starts higher. So we have a line up here. This line up here can be labelled our reactants. So it's the energy the reactants have. And our products have a lower energy. So our products are down there. Now, to get from our reactants up here down to our products down here, we need to join them up. Now, that line needs to go up first. It has a bump, and then we go down. We've got a couple of things we need to add to this. So we get a line going from in line with our reactants to the top of this peak. This line here is something called our activation energy. That is our activation energy. It is something you have met before. We've looked at rates of reaction. We've talked about it. And in case you've forgotten what it is the minimum energy needed to start a reaction. So the minimum energy needed to start a reaction. If our particles don't meet that activation energy, the reaction won't happen. That's our first arrow. Our second arrow goes from our reactants down to our products. And this one here is our energy change. On this one, it will be a negative number because it is an exothermic reaction. So our energy of the chemicals has gone down. It's been transferred to the surroundings. It's left, it's exited, and it's gone to the surroundings, so we'll warm up the temperature. We've now got an endothermic reaction profile. Can you remember what the x-axis on the bottom was called? That's right, it is the reaction progress. And our y-axis along the side, that's right, that is our energy, and it is in kilojoules per mole. For this one, our reactants start lower, so we have our reactants down here, and we have our products up here. To join them up, again, we need that line going up, and it goes over the products and back down again. Now our arrows go slightly differently. We go from it's the same principle. We go from in line with our reactants all the way up to the top of the peak, and that is our activation energy. Again, our activation energy, the minimum energy required to start a reaction. And then we have our other arrow going from our reactants, in line with our reactants, up to our products. That is our energy change. And that is measured in kilojoules per mole. This one time it will be positive because it is an endothermic reaction. So energy is entered into the chemicals, so into our products. Of course, the temperature of the surroundings will decrease. So our final thing here, we've got an exam question. So it says the reaction between calcium carbonate and dilute hydrochloric acid is exothermic. Explain in terms of bond breaking and bond making why some reactions are exothermic. So please pause the video and answer the question. You should now only be watching if you have answered the question. So we want to explain. So we're saying why this happens. So I've got 3 points because we've got 3 marks. We've said that bond breaking requires energy. That's pulling them apart. Bond making releases energy. Now, if more energy is released from making bonds than breaking bonds, the reaction will be exothermic because more energy is being released. So well done if you got that right. If not, our key point there we want to try and remember is our bond breaking requires energy, bond making releases energy. Thank you very much for watching. Please do subscribe to the videos and good luck with your exams. Take care. Bye bye.